on 11.2, there was like that a question where I think it was where it was asking like if the summation of an is times or is convergent and the summation of bn is convergent, is like the summation of a times b also convergent?
Okay. Okay. So sorry, what was your question about this? This was like a true false, right?
Yeah, it was a true false, and I wasn't quite sure how to like. I kind of guessed on this question, but um, I wasn't quite sure like where to actually think about it. Or
That's totally reasonable. So let's just like, this is so similar to integration. So maybe what I'll do is I'll just like, a sub n has some sort of rectangles that contribute to its sum, right?
mm-hmm.
Okay. And basically what we're saying is the area of these rectangles add up to like a finite value if
Yeah.
that series converges. Okay. And then we also know, so that's hypothesis one, we also know that this series converges. So instead of writing them off to the side, I'm actually just going to stack them on top of a sub n.
Okay.
Okay, so that would be like b sub 1. Maybe there's, b sub 2, b sub 3. So we're really doing this in a very geometric way, but the moral is that the whole picture now, like those rectangles, these rectangles' heights are a sub n plus b sub n.
Okay.
Okay, so this is a sub n plus b, sorry, a sub 1 plus b sub 1, right?
Yeah.
Okay, so if I add up the area of all of those rectangles, what am I going to get? I'm going to get that the area of those rectangles was just the sum of the areas of these two rectangles.
Okay.
And these are both finite.
Okay, that makes sense.
Okay.
Now, what if they're being multiplied together?
That's okay, so now I'm going to copy this. Okay, so we've got this, and now we're asking, is this series convergent, right?
Yeah.
Okay. So there was like a similar true false to this. I'm going to say yes. And here's why. Well, I believe, and I think, was it Edwin? Maybe Edwin and I were talking about this, but these, I have to be really careful, but these terms, live inside of the big old sum you would have if you actually took the product of those two values.
Okay.
The reason being is this is actually a sum of mixed sequence terms. If I take the product of two series, you have to think I'm not just multiplying a sub n and b sub n, I'm multiplying a sub n times b sub everything, right?
Okay, so like so like every like so if let's say I is like 1, you would do A1 times that B of that certain term.
Yeah, or B sub 50, right? This
Okay.
one is restrictive to A1, B1, A2, B2,
Yeah.
etc. But this one over on the right-hand side, this thing's got everything. It's got A1, B1, A1, B2, A1, B3.
Yeah. Okay.
Okay. However, this one could have enough cancellation with the other parts that this one doesn't have. So that concerns me. The only thing that concerns me, Zach, is like I kind of want to know that A sub n and B sub n are both positive. If that were a third hypothesis in your question, my answer would be yeah, totally. This definitely converges.
Okay.
Unfortunately, I'm just worried that these terms could have some negatives that are canceling out some of these terms. So these terms could be getting very large, whereas these are killing those parts off.
Okay.
So I don't have a straight answer for you. I'm right now, I would say I wouldn't think that's always true.
Okay. Yeah,
Yeah.
because the answer that I got, it's false.
Oh,
And I thought of it kind of like because throughout the homework we were kind of like separating to like in order to get like a geometric series, you kind of had to separate kind of like the entire equation and to get that kind of like um, geometric kind of form. And I
uh-huh.
kind of like used one of those examples and tested it out, and it doesn't add up to the same. And so I just determined that it was just false.
Okay.
But I just wanted to hear like an actual straight up explanation why. But I guess it's more complicated.
I mean, what you did to prove that it's false is exactly what we have to do. To prove it's false, we have to cook up an example. So there's got to be an example that has all of those hypotheses, not three. If three were there, this would be a true statement. But satisfying hypotheses 1 and 2, that results in this being false.
Okay.
I'm just having a hard time thinking about that because I'm good at taking two series that diverge and taking their product and getting a convergent series.
Mm-hmm.
Hmm. Sorry, I'm just gonna think about it for like give me 30 seconds. 30 seconds.
Okay.
Oh yeah, this is it. Oh yeah. Okay. So, do you buy that this series converges and this series converges?
uh, yes, I
They're
would think
both
so.
they're both alternating.
Yeah.
Yeah.
Yeah, because if you take the limit of a and n equals to 0, therefore it can be convergent.
And
And
they're both decreasing.
okay, yeah,
And so they must be convergent.
okay,
Yeah, good. So they both have limits to 0 and they are both the positive parts are strictly decreasing. So the alternating series test tells you that their series converge. But let's look at the terms in their product. So we'd have -1 to the n over 1 root n, basically -1 to the n minus 1, 1 over n. I'm going to change this to a plus sign here. That doesn't really make a difference. I just want it to be cooler. Yeah. Okay.
They're kind of flip-floppy, aren't they?
Yeah, they're off. Right?
They're out of phase, I guess.
Right, they're out of phase. So what's going to happen is we're going to, so let's combine them. I have -1 to the n and -1 to the n plus 1. So I'm going to add their exponents.
Mm-hmm.
And then we have 1 over n to the 1/2 times 1 over n to the 1/2. What does that give you?
Just 1 over n.
Great. So this -1 reduces to the 2n times -1 to the 1. So we brought those exponents together and then we pulled them apart in a clever way.
Mm-hmm.
What is -1 to the 2 times any whole number?
That would just be 1.
Yep, because that's an even power.
Yeah.
And then -1 to the 1 is -1.
Oh, -1, yeah.
Good. So you have the negative harmonic series, which definitely diverges, right?
Yep.
Cool.
Would any harmonic series, whether it's positive or negative, or whatever multiple of it is, will it always diverge?
Yes, as long as it's a constant multiple that's not alternating.
Okay.
Right. Good. Yeah, -1 over n diverges, -3 over n diverges, but -1 to the n, 1 over n converges.
Okay.
So as long as it's constant.
Is that kind of similar to, instead of thinking of series, but if we think of it as sequences?
How do
Like
you?
if the sequence of a
Yes.
n and b n both converge, then their product can converge.
Mm-hmm. Yes.
Okay.
Yeah. And I think about these a lot, like in terms of integrals as well, because we've just built up so much intuition about those, that this is very similar, right? You like multiply by a constant and the constant doesn't really do anything. It just makes your rectangles bigger or smaller, but that doesn't change if it's infinite or not.
Okay. Yeah. Okay.
Cool. Good question. That was fun. All right. What else do you guys have?